All right, lesson 6 now. We're going to do compound materials. So I'm learning the process and properties of compounding materials, kind of like what Tom is doing here, thinking about what to Jerry. So we're going to learn what those are, what an emulsion is, what a composite is, and the primary physical properties that compounds are modifying. So let's move forward. Okay, so a compound material, like this concrete here being mixed up with cement and rebar, is a material that has two or more substances or chemicals that are mixed together. The mixture is intentional because we want to make new properties. This concrete is stronger with the steel reinforcement, right? And that modifies the existing property of strength. Different kinds of mixtures can create new properties entirely for what we were working with originally. So here we have emulsions. Now, those are a colloidal mixture. Learned about colloids in the last lesson, right? And mayo here is, for example, vinegar, oil, and egg yolk mixed together. Just stirred them up real hard until they became that fluffy white substance. Now, mayo has new properties as an emulsion. Emulsions almost always create new properties, right? It is very different in the physical sense from vinegar, oil, and egg yolks. It is not the same viscosity, not the same flavor, right? This is in many ways a brand new thing out of three things that were different. Now, composites, right, is a material with two or more substances mixed together. Oh, this is a different kind of slide talking about composites here now. So this mixture combines the properties of those two substances. So whereas the mayo is nothing like vinegar in it or oil or yolk entirely, right? It's very different than those things, this weird mixture. With a composite, you get both properties kind of woven together or pushed together. So here we've got straw bricks, right, made out of mud and straw. And we've been using these to build houses since the very first houses were built, basically. And you can see that there's straw in the mud, and those things together help make the mud bricks more useful. Now, composites are usually stronger, stiffer, and or lighter than a similar homogeneous material, right? These bricks break apart less easily because of the straw in them. And they are also a bit lighter because straw doesn't weigh as much as mud. Now let's talk about some of the physical properties that we see and think about when we look at compound materials. The first one here is texture. We can see this big map of a bunch of different textures, okay? And that is, of course, the physical appearance and feel of an object. Emulsions will have a uniform texture. You know, if it's mixed properly into a real emulsion, it's going to be the same texture throughout. Composites, on the other hand, have a more homogeneous surface, but they can be heterogeneous throughout. So a composite like, say, the concrete with that steel reinforcement, the surface is just smooth concrete, right? We don't have any steel sticking out. But inside, there's steel bars in the concrete, so it is not homogeneous, not the same throughout the substance. All right, another one is uniformity. And that's just to describe how homogeneous the object is. How samey is the object? So emulsions, like I said, they're uniform throughout. They're fully homogenized, right? They're all the same, like this butter. Okay. Now, composites are never fully uniform, but they can vary on their uniformity. Some composites are pretty uniform, where you have little tiny pieces mixed into a bigger thing, and other ones are like this reinforced concrete with a steel weave in it. One moment. And that weave means that the object is very heterogeneous, where there's places that are very different from one another. The next property we're talking about is strength. Some elephants pulling on an object in this little picture here. It's a measure of how much force, right? How much pulling or pushing or messing with the material it can take before it is damaged, before something is changed about it. Now, every emulsion and composite has varying strengths because strengths work in all the different like ways you can affect an object. Compressing it, stretching it, twisting it. These are different strengths. Some objects are much better at dealing with being compressed than they are with being stretched, for example. Now, composites typically, almost all the time, not guaranteed, but most of the time, they're going to be more strong for their weight, for how heavy they are, than homogeneous materials. Composites just tend to let you reinforce, improve strength very easily. Now, another property is elasticity, which is a measure of how much a material can change its shape or deform without being permanently damaged, right? Some things, if they get stretched just a little bit, they're already breaking. Other things like this little stretch Armstrong figurine or rubber bands, we can stretch them a lot and they go back to being, basically normal. Now, again, emulsion composites, they have varying elasticities, and there's no kind of like one thing that's true about them. Another property, kind of colloquially, kind of like just to say it easily, is bounce, which is informal. It's not like it's a very technical science term, but it's useful to describe it this way. And this is bounciness is how close to the starting height does a drop object bounce back up to. Basically, if you have a rubber ball and you just let go and it hits the ground, it bounces most of the way back to where you dropped it from. It's very, very bouncy. But if you drop a textbook, right, and it hits the table, it might bounce like this much. Just because it hit the table with such force, that's not bouncy at all. And this is not really depending on a specific emulsion or composite. They can have varying bounciness based off what they're made of. Now, the next one we're going to talk about here is malleability. You can see this here where a forge hammer is being used to press down on this block of very, very hot metal. And so malleability is measuring how much you can hammer that material into a new shape without breaking it, right? If we took a hammer to a piece of wood, we would not expect it to still be a good piece of wood, but we can have that heavy hammer smash that metal and it's still a, quote, good piece of metal. Now, emulsion composites, their malleability is based on the materials they're made of, and there's no specific bonus that composites have in this world. And that's basically it. We cover these 6 physical properties, and we just want to kind of see how you can use emulsions and composites to make even more materials than just the individual substance and compounds that we started with. That's going to be it for today. Hope you have a great rest